Hello my friend, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a very interesting question from entrance examination. We have 2 to the power x plus 4 to the x equal to a to the power x, and we need to find our x. If you have your answer, your approach, you can also write your approach down into the comment section, and then we're gonna check our answers. So first of all, this 4 can be written as 2 square, and this 8 can be written as 2 cube. So let's start with it. So first of all, we're gonna leave this 2 to the x like that without any changes. The next thing, plus, instead of 4 to the x, we're gonna write 2 square to the power x, okay? And we have equal to 2 cube to the power x. So what are we gonna do next? Of course, we need to remember a really important property when we have a to the power x raised to the power y. This is equal to a to the power x times y. So we need to multiply 2 times x and 3 times x. So let's do this as a second step. Let's do this. So we have 2 to the power x plus 2 to the power 2x plus 2 to the power 2x and equal to 2 to the power 3x. So what we're going to do next? Of course, it's really great to have a 0 on the right side. So let's write this 2 to the power 3x on the left side. Let's do this. So we have 2 to the power x plus 2 to the power 2x and minus 2 to the power 3x is equal to 0. Really great. Right now, let's factor. We have 2 to the power x, 2 to the power x right here, but 2 to the power 2x, it doesn't matter. We can easily factor 2 to the power x. Let's do this. So 2 to the power x, we're going to factor it. And in parentheses, what do we have? We have 1 from here plus, we have 2 to the power 2x, we factor 1 2 to the power x, so as a result we have only 1 2 to the x, and right here we have 2 to the power 2x, so minus 2 to the power 2x and is equal to 0. Right now, really important moment. 2 to the power x, we can write it as t, okay? Our substitution in our case, okay? So let 2 to the power x is equal to t. But one really important moment, because this t cannot be equal to 0, obviously, because this is exponential function. This function doesn't intersect with the x, and of course t need to be strongly positive. It cannot be negative. Okay, so right now let's write our substitution. So instead of 2 to the x, we're going to write t. In parentheses, we have 1 plus 2 to the power x can be written as t as well, and 2 to the power 2x we can easily write it as t square. Why we can write it? Because 2 to the power 2x can be written as 2 to the power x to the power 2. We can write it like that, and as a result, this is our t. So we can write it as t square. So plus t square, minus. Yeah, we have minus right here. It's extremely important. So minus t square is equal to 0. Really great. And a product equal to 0 when this t equal to 0, so our first branch t equal to 0, or the second equation, we have 1 plus t and minus t square is equal to 0. The one really important moment, as I said before, t can't be equal to 0. So we reject this branch, we reject this part when t is equal to 0. We reject it. In our case, we have only this equation, so let's solve it. So 1 plus t minus t square equal to 0. Let's change in order real quick. So as a result, what do we have? We have minus t square plus t and plus 1. Yeah, plus t plus 1 is equal to 0. And of course, we're gonna multiply it by minus 1 because we don't need this negative sign right here. So multiplying by minus 1 or dividing doesn't matter. And I'm gonna write it in the middle of the screen because I need a lot of space. Yeah, so let's continue right here. So we have t square, our equation t square, minus t and minus 1 is equal to 0. How can I solve this? How can you solve this equation? First of all, with the basic method, with the method of coefficients, I'm gonna write a equal to 1, b equal to minus 1 from here, and c is equal to minus 1 as well. So let's find real quick our discriminant, and then we plug in it into like all known spot. So our discriminant equal to b square minus 4ac. As a result, we have b square, so minus 1 square minus 4 times a times 1 and times c times minus 1. Okay, really great. As a result, our discriminant is equal to, we have 1 minus minus, we have plus 4 times 1 equal to 4. So as a result, our discriminant is positive. So in this branch, we're going to have two roots. It's also really great. So let's plug in our discriminant into this spot. So in our case, this is our t first, but we can write it as 2 second and 2 third. Okay, so 2 second and 2 third, because this is our complex root right here. This is not real number root, and in our case we're interested in a real number root. So 2 second and 2 third equal to, we have minus b plus minus square root of discriminant and all over to 8. Let's plug in. So minus b, we have minus 1 plus minus square root of discriminant square root of 5 and all over 2 times 1. So right here minus is equal to plus, so we have 1 plus minus square root of 5 over 2. But one really important moment. So we have two roots here. We solved this question, but in the beginning, I wrote that t need to be positive because we are not interested in negative, because with the negative, this is our complex root. We're interested in real number root. And if you see it in your exam, it's also great to solve this question in a real number root, because teachers mostly are not interested in a complex root, only in real number root. So in our case, we have two roots. So t second, let's write it right here, t second with the positive sign. Okay, so we have 1 plus square root of 5 over 2, and we have t third equal to 1 minus square root of 5 over 2. But let's find out what is the sign, what is which these root are complex or real number root, are positive or negative. T second, 1 plus square root of 5 is positive, and 2 is positive, so this root is great for us because we're interested only in positive root. T third, 1 minus square root of 5. Of course, 1 is less than square root of 5, and because 1 is less than square root of 4, yeah, if you're talking about comparing, we can easily find out that this expression is negative. This expression is positive, but this t third is negative, so we reject this t third, because t third is less than the 0. And we are talking about only one. This is our last hope. We have t second. So right now let's solve our question with the t second. Let's go back to our substitution. So 2 to the power x equal to 2 to the power x equal to t. So but, let's write like that, but 2 to the power x is equal to t. So as a result, our equation looked like that. So we have 2 to the power x equal to 1 plus square root of 5 over 1 plus square root of 5 over 2. And from here we need to find our x. There are a lot of ways how can you do this, but the basic one is to apply a log on both sides. So as a result, we have log 2 to the x equal to log of this expression 1 plus square root of 5 over 2. Right now, according to a basic log property, this x we can easily write right here in front of it, because this is our main log property. So we have x times log 2 equal to log, this one without any changes, log 1 plus square root of 5 plus square root of 5 over 2. In the second step, we're going to divide both sides by log 2, and in the end, we're going to find our x. So x equal to log 1 plus square root of 5, 1 plus square root of 5 over 2, and all over log 2. And this is our answer. To our question. So I really hope you understand it. The last really important moment, we can easily, according to a log property, because if you have a log of a fraction, you can write it with a subtraction of two logs, a log of a numerator minus log of denominator. We can easily write it like that. Let's try to simplify this real quick. If you're interested in this, so we have log so we have x equal to, we have log 1 plus square root of 5 from numerator, and minus log of a denominator minus log 2. And we're going to divide both our numerator by log 2. And right now we can divide by log 2. So by parts, we can divide this expression by log 2 minus this expression by log 2. So equal to log 1 plus square root of 5, 1 plus square root of 5 over log 2, and minus log 2 over log 2, which is equal to 1. So this expression is equal to 1. So as a result of a final answer to this question, so log 1 plus square root of 5 over log 2 minus 1. This is our final answer, so we can't simplify this more. So right now let's write it. If you're interested in approximately answer, so I'm gonna write it on the bottom of it. So we have our answer to this question. So x is equal to log 1 plus square root of 5 over log 2, and we have minus 1. If you're interested in approximately answer, I plug in this expression in my calculator, and I get that our x, so if you're talking about approximately answer, so x approximately equal to 0.694. This is our approximately answer. You can easily check it. You can easily plug in this question, plug in this answer in your calculator. So I really hope you understand my explanation. I really hope you understand my solution, and it's also really great if we exchange a little bit about this, exchange information in the comments below. It's really interesting to see your point of view. What do you think about this solution? It's really great, I guess. So thank you for your time. Wish you all the best in your life. Take care of yourself. Don't forget about writing a question, a comment if you need help with these steps. But I'm not gonna lie, this is not a hard question. We're talking about basic steps, basic algebraic steps. We have 2 branches. The first one we reject because exponential function is always positive, and the second branch, this is a basic quadratic equation. Maybe you have a little bit difficulties with the substitution 2 to the power x equal to t, but this also not that hard because with the logs we can easily do this step by step. But if you still have any question, write a question down into the comment section. I think everyone will help you without any problems. So thank you for your time. Wish you all the best in life. Take care of yourself. Have a great day. See you in the next videos.